Thank you. It's very nice to be at the other Cambridge. I thought we had a tourist problem. Yours is worse. It's also nice to be here with this group, which is both policy and technology. And you will see that I think we need to start talking to each other more, or really bad things are going to happen. So let me get going, if I can figure out which way this works. There we go. So let me begin with this adage. My role in life has often been as the canary in the coal mine, the one that dies first to tell the rest of you that bad things are about to happen. And a number of years ago, a friend of mine, Ivan Sutherland, took me aside and said, you know, there's nothing worse in technology than being prematurely right. They will not remember and they'll never forgive you. So I am going to try today to describe a problem that you may not be aware that you are going to have in big data. And so this will let you prepare for it before it actually happens. So let me begin with a story, because you should always begin with a story. When I got to Harvard, one of the things that I found myself in the middle of was the massive online open courses. I was one of the people at Harvard that actually established edX in cooperation with the vocational school down the river. And the notion of these, yeah, that one, MIT. Thank you. Thank you. One of the ideas behind the MOOCs was that we would get a lot of data out of them. The students who were taking these courses, we could actually look at how they interacted with the courseware online and start seeing how it was that they reacted well, when they reacted badly, when their attention lagged. We were going to see every click that they had, and that was a lot of data. This made the educational researchers very excited, because they were used to doing their studies on groups where n was equal to 15 or 20 or maybe 40 or 60. It was some small multiple of the class sizes they could get their hands on. And now we were talking about being able to do randomized trials using the software for the online MOOCs, and at scale of 10 to the 5th or 10 to the 6th. And you tell people that you can do that, and if they're an educational researcher, they get very excited. There were a number that needed to go out and have a cigarette after this. But part of the question around this is, when we get all this data, can we share it? We would like to be able to give all sorts of educational researchers access to this data. Now, people who were inside of Harvard, people who were inside of MIT, we could give them access. But we would like to make this data in some way generally available. Unfortunately, there are laws about this. In the United States, in fact, the law in particular is the Federal Educational Right to Privacy Act, FERPA. It has a rather interesting enforcement mechanism. If you are seen to violate the privacy of your students, you can lose all of your federal funding, which in the case of a school like Harvard that has a reasonable endowment is only about 1/3 of our budget. For other schools, it's up to half. So that's a rather large club. Now, it's not clear that anybody has ever actually lost their funding because of FERPA, but nobody wants to be the test case, because that's very expensive. So the way FERPA sets things up, and by the way, like most US privacy laws, it's really unclear what is meant by privacy in FERPA. But the way it has set things up is that you can either share data by having a point-to-point agreement between the researcher and the institution that is supplying the data. But this brings in lawyers, which means it takes a long time. It is frustrating. You know, one of the characteristics of lawyers, especially in education, is that they want the other party to sign things that they would never allow you to sign. So we didn't want to bring in lawyers. But if you are going to do this in a general way, if you are going to release it as sort of open data, then you need to de-identify that data. Now, what is meant by de-identify? Note, by the way, I do not use the term anonymize. I have worked with LaTanya Sweeney for the past 10 years of my life. We train 30 to 40 students every year in re-identification techniques, to the extent that when a member of the staff of the Federal Communications Commission came into our class and said, you know, we are trying to trace these calls that are being made illegally to people who are on the do not call list. We have this completely de-identified data set, completely anonymous, of all of these calls, and we would love to have students work on this. From the back of our classroom, we heard game on. It was like, no, this is a nice lady. Don't re-identify her data for her, because we don't want to do that. So I have actually trained the Harvard lawyers. This is a hard thing to do, by the way, training lawyers. I have trained them to never say anonymize. They say de-identify. Because de-identify, you can say to what standard. Now, what standard is required for the FERPA law? Having a law school next door, the easy way to find this out was to set a group of law students on the problem. They took about a year, ended up writing a paper that is now often referenced in educational literature on what de-identification is. And their answer was, it's K-anonymity, where K equals 5. Now, those of you that are not in the anonymity world, K-anonymity means that for any record, for a set of quasi-identifiers in that record, and we'll go into this more fully later, there has to be at least K records that have all the same set of quasi-identifiers. And different levels of K give you different levels of anonymity, or at least de-identification. And according to FERPA, K was 5. They said, you know, 3 may be enough, but we think 5 is better. Turns out that's interesting for what goes on later. So remember that. They didn't really quite know, but they thought 5 was good. And if you can do that, then you can make your data set available. So we took the records of the students who had signed up for the online courses at Harvard and MIT, and we de-identified them to a level of 5 anonymity. And we made the data set public. And it was actually kind of a cool thing. All of the educational researchers who did not have access to this data before now could experiment on a de-identified data set. And then someone made the ridiculous request. Had we actually tested to see whether the results that we had gotten from our original analysis of the full data set, were those the same results that we would get from the de-identified data set? Now, of course, the law of large numbers says if you take some things out of a large data set, it's not going to change things that much. We all know this, right? We thought, okay, we will dot the I's, we will cross the T's, we will see what happens if we run the same analysis. And what we found was, it was significantly different. Like really significantly different, like 40 to 60% different in certain cases. And that was puzzling and disturbing. So we asked ourselves, why? What caused these differences to happen? Right? Was it just this data set that we had to worry about? Is it some characteristic of the way that we had pulled this data together that caused this to happen? And we had nearly convinced ourselves that this was the case, because online courses are really weird, right? I mean, tons of people sign up, a really small number of them finish. A lot of the data that we were looking at were things like grades, which were either 1 or 0, right? 1 if they finished the thing, 0 if they didn't. And as people got further and further along in their taking the course, they did more and more things that would individuate them, so they were more likely to be blurred or removed from the data. So, you know, we came up with all of these reasons why it was just this data set. And then one morning, a student walks into my office who had been working at Google as a data scientist over the summer, not a bad gig, and had been given a data set that, because she was an intern, Google had de-identified, and asked to run an analysis, had done her analysis and gotten an extremely counterintuitive result, which her supervisor, a Google employee, then took her code and ran it on the non-de-identified data set, and it came out just the way they expected. So here was a second completely independent case of a data set that had been de-identified and which had given an completely different analysis when using statistical techniques than you would have gotten on the original data set. So, it's at this point that the three most important words of science occurred, right? Science is an interesting thing. And when you do an experiment that gives you exactly the result that you thought, it's nice, makes you feel good. They haven't learned anything. The three most important words in science are these. And those were the words that I uttered at that moment. What is going on here? And so this has absorbed much of my life over the last couple of years. So let's take a look at what was really going on. A lot of this was around the notion of quasi-identifiers. K-anonymity is really a notion of de-identification originally proposed by LaTanya Sweeney. LaTanya, as I said, is a close associate of mine, which is why I never use the term anonymized. And quasi-identifiers are essentially properties that will allow you to link a data set to other data sets. And once you can start linking these things, then you can get more and more information about the individuals in the linked data sets until finally you can individuate them. I point out to my students that this ability to take a set of properties and use that set of properties to individuate a particular person originated in this Cambridge, Bertrand Russell, some time ago, in his theory of names as definite descriptions. So it all goes back to philosophy. This is what happens when you misspend your youth as a philosopher. But this notion of linking of quasi-identifiers is really the core notion on K-anonymity. What you need to do is find all the quasi-identifiers in the set, anything that can be linked to the outside, and make sure that you have rearranged the values in the set so that for any combination of quasi-identifiers, there are at least K other values that have that same value for those quasi-identifiers. Now, there are two ways you can do this. One is that you generalize the values of the quasi-identifiers in your set. That is, you sort of blur what's going on. Instead of having a precise value, you give a range of values. So, for example, instead of saying the age of a student, you give a range of ages. Instead of 20, it's 19 to 21. That lets you blur some of the things. You can go from country to region. All kinds of ways you can do this. Now, this doesn't work on everything. Gender, well, it's getting easier, but it's still fairly binary. But for a lot of the values, you can do that. The other method is suppression. Simply remove the particular record from your data set if you cannot get it to be anonymous to the level that you need. All right? Now, suppression is really just a fancy way of saying deletion. But again, if you delete a small number from a large number, it's not going to make a change. One of the things we found with the first mechanism that was used for gaining K-anonymity in the data set that we were working on is that it was a mechanism that favored suppression, because suppression is really easy, And because of that, even though we had a small number of quasi-identifiers, about 7, out of a set of around 100, well, what was it? It was 1.2 million records. Over 200,000 records had been removed. So you think that things are pretty easy to make K anonymous, and it turns out that that's not true. So the other thing to note is that generalization impacts the full set, right? It's a global replacement of values, whereas suppression impacts the single record. Now, the question becomes, what causes the statistical bias? What kind of statistical biases do we see? Here is one chart that we did. This is showing the mean grade for the students. And remember, mean grade is really an indication of whether or not they completed the online course versus the level of anonymity. So a level of 1 anonymity is no anonymity at all, right? 2 means that there are at least two records with every value. Gets up to 3. One thing to note here, and the further away from the value that you have here, the more bias has been introduced statistically. The further it has gotten from the actual value. Now, one thing to notice is that we only go up to 8 anonymity. It turns out that once you get up to that high, you have basically blurred everything in the data set so that you can't differentiate between any 2 records at all. This gives you a very strong privacy guarantee, but it makes it very hard to come to any reasonable conclusions about how the students are doing. The other thing I would point out is that the decimal value in terms of accuracy versus K is 5, right? It just drops like a stone to 5. And what was the value that the Department of Education decided was the appropriate value for K anonymity? 5. I don't think the bureaucrats actually realized that they were picking the worst possible value. But by sheer luck, or by Murphy's Law, they did. But this is an indication of the kind of bias that gets introduced. Now, I'm not going to glaze the policy people over too much more on this. I will point out that we wrote this up in an article, How to De-Identify Your Data, published in the Communications of the ACM back in 2005. And in this article, we pointed out that the greater your reliance on generalization, the more bias you introduced into the correlations between the various values in the set. The more you relied on suppression, the more bias you introduced in the demographics of the population that you were talking about. And this actually makes some sense when you think that the generalization is a global blurring of the values, and the suppression is a removal of the individual values. So it actually started to make sense. But these are the ways that K anonymity, and for that matter, L diversity, are generally accomplished. It's by using either generalization or suppression in this way, a fairly straightforward binning or a removal of records. So what does this mean? Well, so first of all, I will point out that all of this starts with the assumption that privacy is best guaranteed by anonymity, and that these 2 notions are intimately tied. Now, certainly as technologists, I can understand why we make this assumption. Privacy is a very difficult concept to pin down in any way, shape, or form. Anonymity, on the other hand, can be measured in various ways. We can give actual definitions of K anonymity, or L diversity, or differential privacy. So saying that the two are the same makes it easy for us to say how it is that we are accomplishing the privacy of a data set. But I will point out to you that there are examples of privacy that are very different from anonymity. Right? Anonymous political tracts are not meant to be private. Right? You want to publish these out. Voting, on the other hand, needs to be not anonymous, but it is private. So we have examples where privacy and anonymity are very clearly different. But because that makes it hard, as technologists, we tend to shy away from these. But keep that thought in mind, because that may be one way out of the dilemma that we're going to look at. We also want to take a look at what data science really means. What is the science behind data science? There is the old adage that any field that has the word science in its name is not one. All right? Political science, social science, computer science, well, anyway, data science, right? But what are the core notions of science? Well, I will claim that at least some of the core notions are things like reproducibility. Being able to have someone else do the analysis that you did on the data that you use to come up with the same conclusion. And getting reproducibility in data science often means getting access to the same data set. That doesn't have to mean that. It could mean that they could run their own experiment, get their own data, and get the reproducibility on that. But a common notion of checking somebody else's science is getting your hands on the data. There's also a notion inside of science, at least in the ideal, we won't talk about the primate behavior that happens in science, of sharing your data, of giving other people access to your data so that they can do a different analysis on it and you can increase the knowledge that you gain by having more people looking at it in different ways. And this is one of the real exciting aspects of notions of open data. You don't know what people are going to find as they start doing the analysis on the data that you have generated. They may gain new insights. But if these are the types of things that characterize data science, then what happens if we have this indication that anonymizing a data set is going to introduce statistical bias into that data set? That if we are going to share the data and ensure the privacy of the people who that data was gathered on, oof, that sentence didn't work, then bias is introduced, which means that any conclusion that someone else draws may not only differ from yours, but be incorrect. I would really not have to make this choice between privacy and science and have this be an exclusive or. But that appears to be the case if there is no way of de-identifying the information that is in the data sets without introducing this statistical bias, and if we have identified privacy and anonymity as being the same thing. Everybody with me so far? Feeling good? No. Okay. So, how can we get out of this? Because this is a dilemma that I don't want to have to live with for the rest of my life. I like science. I also like privacy. I think they're both important. So what can we do? Well, among the approaches that we've got are some that are policy approaches and some that are technical approaches. So let's look at some of these. One is what we need really are better models of privacy in the technological sense, right? I mean, come on. K-anonymity, that's so last millennium, right? That's not what we're going to do. We all know better than that. You know, let's go for differential privacy, right? It's cool. It's groovy. There are proofs, and there are no implementations, so we don't know that it's wrong. So it must be better than that. Unfortunately, a number of recent studies are showing that differential privacy actually increases the bias that is introduced as you do queries over the data sets. And this is in the general case. Now, I think some of these studies have come up with pessimal cases for differential privacy. I have to add this because a lot of the differential privacy advocates are my neighbors down the hall, and if I'm not nice to differential privacy, they will be mean to me. But the differential privacy bias is there. I mean, that's really the core of differential privacy, is you blur the results in various ways. And sometimes, especially for things that are fairly rare, the blurring is huge. So differential privacy, while it's a great way of, and by the way, shouldn't be called differential privacy, it should be called differential anonymity. But we all saw before that we want to say that privacy and anonymity, so anyway. It increases the bias, and that's a problem. So maybe the answer is we just don't share our data anymore. Right? It's my data. You can't have it unless you bring in lawyers. Right? Which is the same as saying you can't have it. So that, I think, is a dissatisfying answer. It's dissatisfying not only for the people who have the data, because now how can I ever prove to you that my analysis is correct? But it's dissatisfying for the people who don't have the ability to have the data. One of the claims of a number of schools around the massive online open courses, a number of schools that didn't start off like Harvard and MIT putting these courses out, is that this was in some way increasing the differential between the haves and the have-nots in education. Because we, the rich schools, had access to all of this data that they, the poor schools, didn't have. And that seems like a bad thing. Furthermore, the core of science, if there is going to be a core of science as a community, is that we share our results with each other. We do not want to have proprietary data as the basis of the conclusions that we are drawing. So, simple answer is just say, let's give up this privacy thing. You have no privacy, get over it. Right? Scott McNeely was right. I don't think so. I think this would be a very bad way of approaching the social sciences, because it is only by, in some ways, guaranteeing the privacy of our subjects that we are going to be able to get the subjects to willingly give us the information that we want to study. This is part of the social contract between us and them, that we will not abuse the information that we get from them, and they will give it freely for the betterment of science. Much of this data is sensitive, and therefore we need to give guarantees. So as a philosopher who has hung around with lawyers way too much, the next notion is, well, let's just redefine privacy, right? It's not anonymity. And if those of you that have read the big data report from the President's Council of Advisors on Science and Technology can see some of this redefinition going on even there. In this case, the claim is rather than guaranteeing privacy by having the data be anonymous in some way, we give people access to the raw data, but we watch for a use of that data that would be privacy violating. And when somebody uses the data in a bad way, we will then prosecute them for bad behavior. So it's not that we guarantee that nobody could violate your privacy. What we do is we guarantee that there is a penalty when they actually do. This is a notion of audit rather than a notion of prevention. It makes people somewhat nervous because the violation can occur, and once the privacy violation has happened, it's very hard to pull it back. The right to be forgotten notwithstanding, it's really hard to forget. You may have the right, you just don't have the ability. So even in a case of audit, it means that we would need to develop technology to track the provenance of the data. Because again, once the data is out there, how do you know who was the origin of the violation? There are very interesting cases coming out on this. I had a group of students who took the scraped data from the Silk Road site and started looking at that data to see what sort of identification they could do on the people who were selling things that were illegal to sell. Turned out a considerable number of those ads included photographs that included the geotags. So they have a nice map of where you can buy drugs most anywhere in the world. Now, was this a misuse of that data? They did not gather that data. But this is a case where a violation of the privacy in that data could lead to, if the law enforcement agencies were smart enough to read their paper, the arrest of people who thought they were not going to be arrested. The same sort of thing has occurred in cases of people who have scraped websites and made the data available for analysis. So, where is the provenance in this? How do we think about these sorts of cases? Are these privacy violations because of the use? Or was the privacy violation the gathering? Or was there a privacy violation at all? Because after all, this data was in some sense public. This is why anonymity is so much easier to deal with than privacy. Because with anonymity, we can at least give an answer to what we mean by it. It would mean that we need to take better care of how we do things. And in fact, one possibility might be that we just need better techniques for anonymizing the data than the ones that we have been using. So when we do generalization, or when we do other mechanisms to reach, say, K-anonymity, have we just not thought about the bias introduced and therefore picked the wrong techniques? And this was actually the approach that the student and I, who were doing this work, started to look at. Could there be a better way? So we tried a couple of things. One is to change the way we did generalization. When we first did generalization, we would do it in a fairly straightforward way. We would decide what we thought the minimum size of a generalization bin should be. 5,000, 10,000, 15,000. And then we would go through the records that we were trying to de-identify, and we would fill the bin until there were enough values in that bin. So if we were looking for a bin size of 10,000, and we were looking at age, we would start with, say, age 18, and we would see how many records there were at that age, and if there were 10,000, that would be the bin. If not, we would look at the 19-year-olds. If that gave us 10,000, that would be the bin. We would do that until we filled up the bin, lather, rinse, repeat, until we got out. Different bins would have different sizes, but they all were around the same value. But the student is very clever, much smarter than I am. It's the advantage of being at a place like Harvard, is the students are smarter than you, so you can give them work. The student thought, well, what if I change the binning technique so that I start the way we had, by just filling the bins, but then start to dynamically rearrange the bins so that the values in the bins differ minimally from the mean of the values in the bin. Now, to get this perfect is an NP-hard problem. But to get it close using a greedy algorithm is fairly straightforward. And computing, after all, is cheap. So that was fairly straightforward to do. Then we thought, rather than suppressing, right? Because the way that the reason that you suppress is if the binning doesn't give you k-anonymity, throw out the things that aren't k-anonymous through the bins. Rather than suppressing, we decided instead to add chaff. That is, for every set of values where there weren't enough to reach k-anonymity, we would add fake records. We would add a record that had all the values that we needed to reach k-anonymity, and then we would randomly pick values for everything else. Okay? Turns out that you add a lot fewer records to gain k-anonymity than you suppress to gain k-anonymity when you throw things out. The result, and I'm not going to show you all of the results because, again, there are people who do policy here and I don't want to hurt them. But the result was, you can hurt me later, yes. The result was that the bias, by combining those two techniques on the data set that we were working on, dropped to the floor. It was less than the statistical variation error bars that we would usually encounter. This is what I would consider a promising result. In fact, my wife thought I was having a heart attack because the student mailed me the graphs that she had come up with, and I started yelling in my living room. So, my wife is a very understanding woman. This minimizes the bias in a way that we had not seen before because we had been very, very careful about our techniques for reaching k-anonymity. Now, as I say, this is promising, but let me also say that this is a completely preliminary result. We know that this works on one data set. We need to try this out on a number of other data sets before we can say that this technique actually works. So I am hoping to have the time to do that in the near future. But I haven't yet. Now, this gives us a de-identified data set that we can legally share as open data, and that does not have the statistical bias that we had seen before. But let me make it clear, this does not anonymize the data. If you are clever, if you work hard, you can very likely re-identify some percentage of the data that we would release. You'd have to work really hard on this. And I actually test this with, again, the students that we train to do de-identification. But we are making no guarantees on this. This brings up questions of ethical requirements on researchers. You can release your data with a sort of click-through license saying that you will not try to re-identify this. But we would need some sort of policy mechanism in this to have any kind of enforcement. Because click-throughs are worth the paper that they're signed on. We assume that genuine researchers are not going to do unethical things. We assume that in spite of the fact that we know that that assumption is false in some cases. And so we have to worry about this sort of thing all the time. But we also have to worry about the accuracy of the results that come out of the data that we are seeing. You know, another alternative to all of this would be to allow the statistical bias, but to tell people the open data that we are giving you is only test data. Develop your code, use this data set as a way to debug your code, and then send your code to us and we will run it on the original data set. After, of course, we have vetted it to make sure that it's not got bad stuff in it and that it's not going to leak information. Is that really the kind of service bureau that any of you wish to become as a researcher. And this has an operational overhead that most researchers are not willing to put up with. But is that what data science is going to require if we use it in the social sciences? We all know that in data science, the science is only as good as the data. Right? Garbage in, garbage out. By the way, that doesn't mean that if you don't send garbage in, you won't get garbage out. But we do know that if you put garbage in, you're not going to get anything better out. But we now have conflicting requirements. The requirement of accuracy, the requirement of doing good science, seems to be at odds with our ethical requirements of protecting the identities of the subjects. We need to think about that. Most of the research I have seen on de-identification of data has concentrated on how difficult it is to re-identify individuals in the data set after the data set has been de-identified. And that's not the only question we should be asking. We need to ask the question of what the de-identification did to the data set itself. Can we share that data set and make conclusions out of that data set that are accurate? Can we measure the kinds of bias that are entailed by the de-identification mechanisms that we use? Can we quantify it in some way? So is this the additional error bar that we now show in our charts? Not just the statistical confidence that we have, but the interval of confidence because of the de-identification. We haven't thought of those things. Or at least most people haven't thought of those things. And we have to. So I'm not saying we have the answer. Right? This is the other advantage of having been trained as a philosopher. I'm fine with questions. Right? Once as a philosopher you can accurately give the question, you're done. It becomes a science then, and you don't do it anymore. And the real wisdom in philosophy was all summed up by Socrates, who knew he was the wisest of all men because he didn't know anything, but he knew that. So what I know is we have to choose here. We have to be careful here. So when you're out there de-identifying your data, be careful. It's dangerous out there, not just to you, but to your subjects and to the people that are doing science based on your data. And with that, I'll see if there are any questions.